Welcome you all for the seventh session. Let us see a new data structure which are sets, and then how it is implemented. Maybe I should introduce hash functions before sets, but I thought I will introduce what are sets, and then we'll talk about why we need to discuss about hash functions. I'm sure you might have studied in your data structure program courses. So the focus of this session is going to be this school. In your school you might have studied set theory, and then we will talk about the features of sets implemented in Python, and then how hashing helps in implementing sets. Then it also helps in having a implementation of dictionary also. We will cover it later. Okay, so far what we have seen: strings we have seen, and list. Now list is a collection or a container. Okay, we call it as a container. It can key it can have any number of any kind of objects in the list, and we can iterate over them. It's ordered and mutable. We can modify it. So these are the properties we saw about lists. Now we are going to learn about sets. Before that, I will introduce you to set theory, and then we will see how does the set differ from list. Now in mathematics, a set is a well-defined collection of distinct objects, set of polygons. We call them as a set because they all, maybe somehow they are related. The relationship need not be in terms of their types. It could be based on the application. Like you can have an employee data as a set, but the employee data may have different data types: name, address, age. They are all different types, maybe salary, but they are all in a set because they are related in some way, because it's talking about a particular employee's data. So similarly, set is having a collection of data which are related normally. That doesn't mean that they are of the same type. They can be of different types. The arrangement or order of the objects in the set does not matter. It is like you keep it in them and then you uniquely take out, but there is no order maintained inside them. Okay, when it is maintained inside the set, it's no, it's not ordered. A set may be denoted by this. I will talk about the flower bracket. Okay, this is common for even dictionary also. Now, how does the compiler differentiate whether you are having a set or a dictionary? If you have a set of elements like this, it is a set. But if you are having a key value pairs, okay, key value, then it is a dictionary. That means you are having a key which refers to a value. So we use the flower bracket for both sets as well as for dictionary, which this dictionary we will cover later, maybe in the next class. But Python uses the same syntax for both. Like list, it uses square bracket. It uses this for sets if they are separated by one element, not a element followed by a colon, and that having multiple entries. Then they are dictionaries. Okay, that's how the compiler of Python differentiates between whether you are trying to define a dictionary or a set. Okay. Now I forgot about tuple. I think we saw tuple also already. So sorry, tuple list we have seen to know both. Tuple is Let me talk about tuples. We said that it is to be covered by parenthesis and then a comma b comma c. Actually here the parenthesis is optional. Even if you say ABC, it means that it's a tuple. Okay, that's why when a function, you have a function something and then it returns a comma b comma c. So you can give any number of objects and then list them out, or not. When I mean by list means it is, I'm not talking about this list. List of items separated by comma means that it's a tuple. Okay, you could do this, otherwise it assumes that it is a tuple, and then this function returns a tuple object constructed with these values, and you get the, when you assign it to the, when you are calling this function, you may assign it to either like this or you may do this. Both are same, both are acceptable. Or you can just say that it's a tuple object, then it will be pointing to the object which is a tuple. So remember that you can individually assign them, which is unpacking. Okay, you can unpack it and then assign it to individual variables, or you could have a one single tuple object which is pointing at this object which is coming from the function. So tuple is a list of variable items which are separated by commas. Okay, that's what we learned last class. So here we are going to see sets. I don't know whether there is some sound, so let me check whether I am still connected to you. Okay.
Yes, sir, you are connected.
Okay, fine. Thank you. I can't tell you that. Please let me know when I am not connected. It is like those who are absent, please say raise your hands. So I need to come myself and see whether I am still talking to myself or talking to you. Okay. So far I hope things are clear. Now you know what I am going to show you. Very good. So universal set A, B, two sets, A union B covers all the elements in them. A intersection B and A difference B, A minus B. The color shaded area is what means what I am saying here. Elements in A but not in B. Here elements in B, not in A. Difference of B minus A. So A minus B and B minus A are different if the sets are different. And this is something symmetric difference between A and B. Elements in either A or B but not both. So here we are referring to the elements which are shaded. So elements which are in A or B but not in both. Okay, this intersection is removed. So universal minus U minus A intersection B is what is a symmetric difference. So since sets data structure is based on the set theory, so all these operations can be performed using some symbols as well as library functions. So we will see today with library functions how to do this. Okay. Now what are the features? Set is a collection, as I mentioned, unordered. There is no ordering maintained within the sets. The set itself is mutable, iterable, and unindexed. Okay. That means if it is not ordered, you cannot index them. So it's unindexed. So set has a non-duplicate members which are immutable objects. Now it is a non-duplicate. One more important thing about set is you cannot have a duplicate element. So that's not allowed. It doesn't allow duplicate elements, but it doesn't maintain any order, but it makes sure that there is no duplicate maintained within the set. Now the question is, how does it go through it? We will see it. That's where hash function comes. How, when you are iterating over the list, or when you are trying to fetch one item from the list, set, how is it accessing a particular element, whether it is present or not? So that is, it uses a hash function for that. We will see that. So they are non-duplicate elements, but they are immutable objects. So they themselves cannot be changed. Okay. So let me tell you, before we discuss about sets in detail, the difference between dictionary and set. So I said that A, B, C, a list of some sequence of elements which are not ordered, is a set. And we use a flower bracket for both dictionary as well as sets. Now dictionary will have maybe A is a key and val 1, and then B colon val 2, then C colon val 3. Now this A, B, C, which are called keys, and this is value, and every element in a dictionary is a key value pair separated by colon. Now what is the uniqueness of key? Key has to be immutable. Value can be mutable in a dictionary. Okay. Now we can derive a set from a dictionary by knocking off the values. If you are picking up only the keys from a dictionary, it becomes a set. Okay. That means what? These elements which are immutable are given here. That's why I said that it's a immutable objects. What you have in sets is immutable object. That means they cannot be modified. Now then you will know that you cannot have a list as a key, because the list is a mutable object. Now can I have a string as a key? Yes, you can, because string is not mutable. So you can have a string as a key but not as a list. Now I told you that in a dictionary we knock off the values which are mutable and then take out only the keys which are immutable. Then we get a sets, and these sets are nothing but a sequence of unordered immutable objects. Now why is the need that we want the sets to have immutable objects? Now let us see that. It depends on how a set, I'll call it as a set, my set, how this set is maintained or managed inside the library, and how it is accessed. Because when you want to look for a particular value, you will be looking for that, and then it will give you, okay, that whether it is there or not, and if it is there it will give you. Now when it is searching through this, it uses a hash function. Okay, I will talk about the hash soon. For this hash function, you can call it as a function which is returning an index. Okay, it returns an index which will help this library to access a particular element. Suppose you are looking for a C, I pass a C to the hash function, it returns me an index 3, then I will go and see the third element should be this. Okay, it is somehow maintained like, I use this hash function to know whether the particular element is there, and if it is there, what is the where exactly it is inside the set. Now this hash function is computed for a given object in some mains. How is it done? It is done by looking at the content of this immutable object. Suppose if you are giving a string name, and then this is another string ABCD. Since they are immutable and they are different, they are not duplicate, certainly you will have different objects with the values, different values. So the hash function, when it is given to it these different values, it will return different indices which can be used for accessing the element inside. So we will come to that soon. The reason that we don't want these objects which are there in the set to be immutable, because we want to have the hash function returning the same index every time I access it after it has been added to a set. So I don't want that to compute something else. So we are going to be very strict about having only immutable objects within a set. Now, I may have a different object. As I said that it could be any kind of object, different object, but if you see that they're all immutable, tuple is immutable, you know, my string, and then any float value or integer values are immutable objects. So they can be formed as a set. So set allows tuples. Now it allows tuples only if they contain immutable objects, because you saw that a tuple itself can have mutable objects also, but set allows a tuple only if it contains a sequence of some immutable objects. Now why is it so? Because it is going to compute based on the contents of the object, and then the hash function is going to return some index. If this is changing, then its contents will be different and the hash function will return something else. So every time when I am iterating over it and looking for this particular object in the set, I may not be able to locate it because there is no ordering maintained. The index is computed based on the contents of those objects. So I want those objects to be immutable. So tuple as such may allow the objects to be changed. So because what it is pointing at could be changed, which I mentioned it in the last class. So we need to have a tuple only which are having immutable objects so that we can compute the index using the hash function. Then it can be indexed into the set. So that's the reason set allows tuples only if they contain immutable objects. You know that tuple themselves are immutable, but it allows mutable objects, which I told you earlier. So tuple has the flexibility to have mutable objects, but such tuples cannot be a member of a set. That's all. That's the only limitation. You can have a set only with having tuple if it has only immutable objects in them. Okay. I told you the reason also. Here, sets themselves are immutable. Okay, it's a reverse of the tuple. Sets you can keep adding more elements. Okay, sets is mutable. I said set is mutable, but the objects that they are there having are immutable. So sets themselves are mutable. It allows only immutable objects, whereas tuple themselves are immutable, but it allows mutable objects. Okay, it allows both immutable as well as immutable object. Here only immutable objects. Please find the difference between them. Okay, tuples, they are themselves immutable, but it allows both mutable and immutable objects, whereas set are mutable themselves, but they don't allow mutable objects in them. Okay, the reason being computation of hash function index. So sets provide methods for constructing and manipulating unordered collection of unique elements. Now, I mentioned that you cannot have duplicate, okay, non-duplicate members. So unique elements, every element in the set is unique. I cannot have one more number 2, one more 3.14, because it may be converted into a floating point representation, but still these values, the string is same, so it will not allow you to have immutable, same content, unique. It needs to be unique. Now, what are the uses of sets? Membership testing, different uses of sets. You can test whether a particular member is part of a set or not. Removing duplicate from a sequence. Suppose if you want to, you are getting a list of numbers and you want to remove the duplicate, what you can do is you can convert it into a set, okay, and then convert back to list. Then all the duplicate elements in the list would have been removed. So you can do some conversions, very straightforward, very easy to do that. But it allows you to remove duplicate elements because sets themselves are having non-duplicate members. Performing standard math set operations like what I showed you on sets such as union, intersection, difference, symmetric difference, etc. So sets do not support indexing. As I mentioned indexing, slicing or other sequence-like operations. It doesn't allow any of this because if indexing is not allowed, you cannot do a slicing on it. Okay, you cannot say that I want it from to set of in an increment of step. This is start, end, and step. So I cannot do this slicing on sets. Sets do not allow mutable elements such as lists or dictionaries or tuples with mutable objects. So a tuple should have only immutable object. Lists themselves are immutable, so they are not eligible candidates for having them inside a set. Sets themselves are mutable, but it can have only immutable elements. I am just telling this, such as basic types int, float, strings, and tuples with immutable objects. Okay, I am just summarizing it. It is though it is mentioned here. Any questions so far on this? Okay.
Sir,
Yeah, go ahead.
sir, I have a question like as you already talked. So the syntax for creating the sets and dictionary. So how to differentiate Python Maven? It is a set or it is a dictionary.
Okay, I will anyway show you the code. We will see that. Okay. Even I would say that differentiating between whether you are passing a parameter or are you constructing a tuple, that is also confusion is there. Bracket, parenthesis, inside them there are some elements separated by commas. Similarly, a flower bracket with the element. Now suppose I'll tell you a dictionary. So the confusion will come only how to differentiate between whether it is a dictionary or a set. So because both are having flower bracket. Now, how do you know if the objects are like this? It is a set. It can't be a dictionary because dictionary need to have a key value pair. They are not. There is no key value there. Whereas K1 V1 K2 colon V2. Okay, I put a comma, so let me complete it. So this is a dictionary. Okay, so based on what you fill in, the compiler can easily identify whether you are constructing a set or a dictionary, because you are not going to define any type here and then a variable my dictionary, something like that. You are not going to do. So there is no type. You are going to give a label. So internally it has to know what type of object it is creating. So that's compiler needs to be aware what you are trying to do. Okay, it's not going to look at your variable name and then find out, okay, you are constructing a dictionary or a set because I said my set, then it is a set only. So it is not going to look at the value. I can say my dictionary and then assign a set. Nobody is going to catch me. Only the person who is maintaining my code will certainly curse me, or he will search and then come to my house and kick me also if I say my set and then assign a dictionary to it. So compiler needs to know what you are doing and what you are assigning. So the object what it is creating, what type it is after it is created, or while it is creating, sorry. So it is I hope you are able to understand what I am saying. This will tell the difference between whether dictionary or a set. Is it clear?
Yes, sir.
Okay, thank you. Any other questions from anyone? Immutable, mutable, all that little bit I am saying that. Okay, don't worry. All that will become clear when you see the implementation. We will spend maybe two classes on this. This I have covered. Now sets basic operations. These are all length you have to apply on it so that you can find out the number of elements in them. You can iterate over it. Okay. You cannot index. When I say, see, there is another difference between, I said that indexing is not allowed on a set. I also said slicing is not allowed, right? Colon this, it's not there. But that doesn't mean that I cannot iterate. Okay, they are different. Only thing is, when I say indexing, I cannot say I want a 0th element, I want the first element. I can't say to get it from there. But I can say that I want one element from there, get me one element. It is like I show you a bag and then full of chocolates, maybe different types. You put your hand and pick it up. You cannot say that which chocolate I put it first in the bag. So you just take it out, whatever you get it, you get it. So similarly, when I say X in S, I get something, but that what I get need not be the items, the order in which I put it inside. Okay, remember that it need not be the order in which I put it inside. Similarly, if I have a set, okay, some elements are there, I iterate over it. Okay, now I add some element, suppose. Okay, I add something to the set. Okay, some more element I add. Now again I iterate. The order in which those items came, they will be different. Okay, now it could the new element what you have added could enter into anything anywhere in between, and what you get as a first or a second, third, fourth element, there is no order maintained. Okay, it depends on the way it is implemented and the way keys are computed and how it is indexed into the set. So you may iterate it over, but you cannot expect some ordering the way you take out items from there. So you cannot have any dependency on saying that, okay, I iterated over the set last time, I got this as a first element, now I have added more elements into the set, now the first element what I get will be the same as what was given earlier, or what I got earlier. You cannot have an assumption. So you need to always keep in mind, when you are iterating over, you don't maintain any order in which those items are going to come. But you will get it. You can find out whether an element is there or not. You can find out membership. You can find out not there. You can find out. You can iterate over, no problem. And then is subset, superset, union, intersection, all the set operations you can do. I mentioned that there are operators also, so I can give it as a home exercise that you can try it out, or we can do it ourselves. We will do it in 2 classes maybe. I'm going to do this today, maybe sometime we will do this, so that we know both how to use them. Okay, so let us not go very fast. I want to make sure that whatever I tell you, you get it into the head. My aim is not to rush through. Please tell me if I am rushing through. At the same time, I should not be boring you also. So I need to really have a balance between them. So please feel free to tell me, sir, you are going very fast, slow down. Or tell me that you are too slow, please go fast. We are getting sleep. You may get sleep even whether I am going fast or slow, but still, I should not be inducing sleep to you, hopefully. Okay, so you can understand what they mean. Copy, I mentioned about deep copy and then shallow copy. So you need to have a different function, which is deep copy is there. Okay, that also we may see. Deep copy does every element it creates again and then copies it, so that if you modify something, it will not be affecting it. Okay, shallow copy, if you want to add something, or you can have a shallow copy or deep copy, whatever you want. Okay, now what are the other operations apart from something which you have seen? Okay, there is a pop, the push and pop stack operations. This pop, there is no particular element which will come, random element will come out. Okay, so it doesn't guarantee you that if I created a set with adding element one after the other, when I pop, I will not get the first element, or there is no guarantee that I will get the last element. I will get I may get any element that I have added. Okay, random. It is purely random. It's not purely random. It's not that every time when you do pop, you are going to get a different items. As long as the number of the individual elements are the same, every iteration when you do, if you run it again and again, the pop will give you the same value. But don't get confused. Okay, what I'm trying to tell you is, when I say random, do not use it as a random seed. Okay, it's not like a random seed. Random seed really gives you, if random value, random function, if you are seeding it with a different value, it really gives a pure random value. Here it says random, that means do not assume it to be a random number. You cannot use a set for a random number generation, neither. But it is purely random in the sense you don't know in which order an object, when you add into a set, will get added. Okay, in which order it would have got added, and when you run a pop function on that, which element you will get is also not guaranteed, because I'll tell you, because it is dependent on the hash function, and that hash function, this computation is based on the content of the object, what it is pointing. Okay, you remember, always that they're all references. Okay, all of them are references, none of them are anything other than reference, an object pointing to some object. So if a hash function is computed, it needs to look at the content. Okay, you cannot go by the ID of this addresses and then come up with the hash function. Hash function really scans through your every object, and then whatever the content, it could be a list, or it could be a string, or it could be a floating point number, or it could be a tuple with immutable objects. Then it will go through all the contents so that they are all constant, they are not going to modify, they are not going to be changing. We are not passing a list which is going to be changing. So it will compute a hash function, which is a collection of the effect of all the contents of those objects. So you are going to get the different element will get different hash functions. So when you add a new element, the hash function may be different, and that index, index is based on the hash function output, right? So you may have a order getting modified when you are adding an element or removing an element. That's why I said pop does not give you exactly the same element. Okay, so it will give out something which is random in a sense. So clear removes all the elements from a set. So that means it makes an empty set. Clear makes an empty set and then gives you. Update adds multiple elements to the set of by union of itself. Okay, so I will talk about this with an example, how these two are different. Okay, add and update are different. We will see with an example rather than going through it, but let me explain. Here you add an element. Suppose if you are adding a string, okay, as a single entity into a set, okay, then you use an add function. Update, what does it do? Update function, if I give a string to it, it unpacks it. So it goes, every element it takes it out and then puts it into the set. Okay, so adds multiple elements to the set by union of itself with others. Now you see here, union of itself with others. So let me explain what this particular sentence means, the whole sentence. Okay, why should it give a union? Okay, why should it give union? Now suppose you have a set. Yes, let me call it as S1. Let me call 1, 2, 3. Now S1 update. Okay, I am feeding maybe a string 2, 3, 4. Now it unpacks it. That means it takes 2, it takes 3, it takes 4. Already S1 is having 1, 2, 3. So when it takes out 2 from this string, what you gave, adds multiple elements. So each element it takes out to the set. Which set? S1. by union of itself, that means union of S1 with the others. So it performs a union operation. Then what happens when it performs a union operation with this, it will get the same set, okay? Because union is already there, duplicate elements are not allowed. So 1, 2, 3 will not get another 2. Similarly, when it tries to do a union operation with S1, it gets the same set. So 1, 2, 3. 3 is also not going to get added. Now when it gets 4, union operation will get in 2, 3, 1, 2, 3, 4. So whenever you are adding an element or any set of objects, either you use add or update, it will verify that that particular object is not a duplicate in the set. So that it takes care. These libraries will take care. Now, okay, when you are using add and update, you are taking care of it. But what if, suppose if I have S1 equal to, I say 1, 2, 3, 4, 3, 4. Okay, if I say this, what I get finally added is 1, 2, 3, 4. So this duplicate element, it is not going to give you an error or say that, oh, no, you are giving me a duplicate element. It will not give you any error, but it will quietly remove the multiple copies in them and then gives you this. So that's why I said you can use a set function to remove duplicate elements. Suppose if you have a list with 1, 2, 3, 4, 3, 3, 1, 2, 3, 3, then if you form a set and then you transfer it to list, then what you get will be 1, 2, 3. So if you go through this transition, you are removing the element which are duplicate, because list doesn't bother about duplicate. But remember, when you are going through this, you are going to disturb the order. Okay, that you need to keep in mind, because set is not going to preserve the order. So whatever element you get out of it, it may not be in the same order that you have given. So that you need to keep in mind. But you can remove the duplicate elements from the list. Okay, fine. Now let me talk about hashing. I don't know whether I'll have time for showing you the example. It doesn't matter. We can run through the example in the next class also. Okay, I don't want to rush through, as I mentioned. So let me see if there are any questions before I go into hashing. Anybody wants to come online? Okay, fine. Now let me explain hashing. See, why do we need a hash? You might have used the hash in your algorithms, the courses. You need a hash when you have more number of elements. Okay, dictionary is one place where normal dictionary, what you have, the number of words in the dictionaries are going to be huge in number. Okay, so when you want to index them, you need to, suppose if you are having a total number of possible elements that you can get in a set, if you know that there are 10,000 elements which are expected to be in a set. Okay, set is used for set, or a dictionary is used for huge number of items, but it is implicit that not all the elements will be there in a particular time, but you may keep adding and deleting, removing, all that. So if you use indexed way of addressing it, you need to have the array of, suppose 10,000 elements you expect this dictionary to have. You need to have an array of indexes. They may be null. Okay, maybe some of them do not have an element right now, but you need to have an element, entry made for it. Okay, because you don't know when an element falling in this particular index might come into the get added to the dictionary or a set. So what happens is you will be wasting the space of maintaining a huge array of pointers, because it has to point to the object, right? So every object, if it is corresponding to a particular index, then I need to have a location, an array of pointers. Maybe initially it is filled with null, but later on when an element with this particular index is added, I may have the object, real object, getting added to it. So it's a waste of space when you are maintaining such things. Okay, so direct addressing, this is called a direct addressing. Size of universe is huge, then your size of table should also be that much. When I say universe, means universe is this whole set. You may have this, any element can be in A or in any element can be B. So you need to have a huge table. The size of table will be equal to the size of the universe, number of elements that you can possibly have. Impractical when it is very large. So now if you have a hash, you use the key, which are the actual keys or the element values, and then you compute the hash function, okay, which will be still again distributed. It will not be same. Sometimes the hash keys will be same, then you may have a clash there, but it is supposed to be distributed equally. Then what happens, the advantage is that you don't need to scan through it, okay. If it is a huge array, in terms of memory, suppose if you are a limited main memory you have and the huge array is in the hard disk, you may have to get the even this array, index array into it and then process it. That kind of things will be there. But hash functions, when you use, you will be restricting to some list of values, and then it can expand it based on the type of element you add. It will keep expanding, and you choose the hash function in such a way that they are only m to m elements, okay. Though the number of possible elements are more, your indexing is within this limit, because hash function is limited to give you an index which is within this limit. Then you are restricting it the total size to only n element. So that is an advantage of saving space using the hash function. So key will be within this m-1 or m element. Index, the hash function generates an index into the table, which in turn points to the object which which is what it is. Now real content of that, okay. Remember, the key is different from the actual content of the object, because the actual content, based on that, keys are generated. So you may have a collision here. So the hash function reduces the range of array indices and hence the size of the array, and it's very large. M is not, okay. The size of the universe is very large, but M is not. Search time is order 1 if there is no collision in searching with the HK. So if there are no collisions, you can search it in order 1, okay. The ordering is, the complexity is order 1. It doesn't increase based on the number of elements. Simple uniform hashing is achieved. Uniform hashing is achieved so that you can avoid collision. It is always finding some empty slots by choosing h of k such that the set of keys to be stored among the m slots are distributed equally. So if you want to store m keys, it is distributed equally, so you don't tend to have a collision in the key, okay. So thus reducing the collision. Now how do you search in the sets or a dictionary? Now please remember, the hashing is used in sets as well as in the dictionary, okay. A dot val, okay, comma b dot whatever, so colon c. So this is to access the key, you will be using the hash in the dictionary, and then once you find that index, it will be pointing to the value which is there, okay. So you will be searching for a key in the dictionary, and then once you find it, using the hash function, you go to the index and then access the value that is paired with this key, okay. That is how dictionary is accessed. Since elements in a sets are to be hashable, only immutable objects are allowed, as I mentioned it. Hashing means using some function or an algorithm to map object data. As I told you, object data is used for computing the index by the hash function to some representative integer value, which is an index into a table. So that is a function, that is job of a hash function. The hash code, or simply hash, the implementation, can then be used as a way to narrow down the search when looking for an item in a collision, okay. So what you do is you do a hash and then you try to find out, once it is within the thing, you can always find out the individual element. Okay, when looking for an item in a collection, you can find out based on the hash function. So in a collection, if you are looking for a particular element, you compute the hash, go to the index, then you are accessing the object. The hashing and the hash values need to have the following properties. Now, what are the properties of hashing and the hash values? Hash value is what you get from the hashing function. They need to be deterministic. That means whenever you pass the same object with the same content, it will return the same index, which is indexed into a hash table. Same message or key or data should result in a same hash. Sometimes hash value is referred as a hash. And then it should not be too complex. It should be some XOR operation or some binary arithmetic operation, so that it is how much time? Okay, it is not too complex to compute it, and then infeasible to generate a key from a hash. It should be in such a way that you will not be able to get the key from the hash. Okay, it is for the safety purpose. Sometimes to avoid backtracking it, so you cannot nobody should know what hash function you are using internally. Infeasible to find two different messages that yield to the same hash value. So you want to avoid the collision, because then order of one is not guaranteed, and then how will you resolve once the collision happens? So you should be possible to have whatever is implemented in this Python. It tries to make sure that there are no two different messages that yield the same hash value. Okay, you should not, two different messages should not give you the same hash value. At the same time, same message should always give you deterministic. It should give you the same value. See, remember, you may be wondering, how does the set know whether a particular element is there or not? So when you are passing set, already you have a set with the ABC. Okay, and then you are saying that add a. Now it is going to compute the hash function. Okay, it is going to give, hash function is going to be passing this, a is going to be passed to it, and then this index is going to be used here. And if index is null, that means that element is not there. If it is already pointing to some object or it is filled, that means this object is already there. Then it will say that there is a collision or it's a duplicate function. That means what? Every time when you compute the hash function for a given object, it should always result in a same hash function. So it is deterministic. Similarly, if this a is resulting in a hash table entry here, when I pass a c, another function, another object, I should not get the same thing. There shouldn't be any collision. It should give me a different thing. If there is no c in the set, it should give me an empty place where I can put it. So it should be deterministic, as well as it should be infeasible to generate the same hash for a given message. Hash collision should be avoided. Similarly, a small change to a message should change a hash so extensively. That means you should, then only you can have a uniquely uncorrelated distributed keys, so that you don't get into a collision always, and you are managing the hash table properly. Okay, so what is hash function in Python? It's a fixed size integer which is coming out. Hash function generates hash based on the contents of the immutable object. I told you each element is added into a set by indexing into a hash table with a hash. When an element needs to be searched for it, hash is computed again for that object, and it is located within the hash table. Okay, searching for a hash is much faster, order 1, compared to searching for a huge searching for an object within a set, because they are expected to be huge. So, compared to searching for an object, computing hash function and then going to the table is much faster than looking into every entry in the table and then looking for whether this object is there or not. You have to go make an object comparison for that, which is very expensive. So set allows only immutable objects to be there, because hash will change if mutable objects are allowed to change. Reinserting the object whenever they change is an expensive operation. Okay, so you cannot if you are changing the object, then you need to remove it from the hash table and then compute the hash table hash function again and then add it. That's why immutable objects are only allowed within a set. and then a small change should distribute it equally so that it doesn't have a collision. Who implements the hashlib module of Python implements it. Okay, so I have explained the hash now. We will not see the code today. We will see it in the next class. Okay, I think I am coming to the end of a class, so we will have a lab. Okay, anyway, I don't have to rush through still, but still I am supposed to give you gap. Okay, any questions, guys? So what I plan to do in the lab till today, I will give you the list problem. They will maybe, if you want the solution, you want me to go through the solution that the problems that I gave you in session 5, I can do that. What I have implemented, I have seen that many of you have implemented and given. So it looks like all of you have done it, understood it. If it is not needed, we will not look at the solution. So I will give you a couple of problems, a couple of more problems. Okay, not very complex, but I want you to use recursive method to implement it. Okay, that let us see. If you want, I will show you my solution, or you can solve and then give it to me. We can open another entry for it so that I can get the recursive implementation of yours before I influence you with my implementation. Then we can look at the solution. So since you have already submitted the session 5 solution, so I will show you my solution, and we can follow the same methodology for recursion also, whatever we are doing today. So whatever we do in the lab, maybe I will ask you to submit it so that we can keep you are forced to write those code and then become ready for the exam. And programming is not possible unless you practice yourself. So let us do that. Okay, any other suggestion? I am open to any suggestions. Please let me know. Any questions before we break? I hope whatever I explained today is clear, or whatever in the class. We will look at the sets tomorrow by implementing, showing the code, and then implementation we will see. Okay. Okay, no questions. Then bye bye. See you at 8 p.m.
Thank you, sir.
Yesterday we covered about sets. So just I will give a quick wrap up on what we covered yesterday, so that when we write code, you are all tuned to what is taught to expect. So we said that sets are unordered, in the sense when you add it based on the hash value, it computes for the contents of the objects that you put in. They are put into the set, and when you take it out, they will also be taken out in that order. It is not based on any specific order. It's based on the value of hash that it computes. And we said that the set is mutable, as such you can keep adding to it or deleting it from there is allowed, and it is iterable, but it is not indexed. You cannot index it because there is no order maintained, because it is all based on the hash value that you compute. Since the items are added into the set based on the hash value, the objects that you give it should be immutable. The objects need to be immutable, what is given to the set, but set as such is mutable. You can keep adding or deleting items from there. So there is a major difference between tuples and sets. Tuples themselves are immutable, but it allows mutable objects, whereas sets themselves are mutable, but it allows only immutable objects. So it is only here, which you should remember. And then these are the operations we saw. Set theory, whatever we have learned in our school, all the operations can be done on the sets. And these are the symbols which you can try it out later. These functions, we will try to look at it now. Hash, I explained you. It's some algorithm or a function with which is not too complex. At the same time, it gives you the value which is distinctly different even if the items in the objects are having minor changes, the hash functions are distributed equally so that it will not have any collision while looking for the entry in the set. Thereby, you will be able to add them and maintain them in a set. Okay, the hash functions are designed such a way that there are collisions avoided here. And searching through the hash table is order of 1, because if collision is not there, for every object that you have, there will be a unique hash value that you will get it, and you will be able to locate it within the table, and it's order of 1 and not if you increase the number of elements in the set, it doesn't increase the search time. Okay, that's an advantage of having a hash function to access these sets. So whatever you learn in sets about the hash function, it is true for dictionary also. Only difference is dictionary will have keys, and then you will use the hash function to locate the key, and then it will give you a value for every key that you have in a dictionary. So that we will learn in the next class, in the next week. Okay, so that's what we learned about hash as well as the set. So let us start writing a code now. I mentioned that flower bracket is what is used for keeping the items into the set. We keep like this, and then dictionary will be having a pair of values like this. So both are flower bracket. This is dictionary and this is set. Okay, so now let us see empty equal to this. Now what do you think this is? Is it going to be a dictionary or a set? If I say this and then try to find out the type of that object, will I see a type defined as a dictionary or a set? So let us see. It's a dictionary. Okay, so Python accepts or treats the empty flower brackets as a dictionary and not a set. Okay, now how do you create an empty set? So empty set equal to set and this. So this is like a constructor. We are constructing a set object with no items in it. So if you type that, it will be a set. So we have created a set now, empty set. Now I hope this is visible. Maybe I will increase it a little bit. Now let us form my set 1. There is no issue here. So let me create another set, maybe with duplicate items. Now what happens? One more property of set is it will not allow duplicate items to be there, and you know that it maintains the object references. So let us see, when you do this, what happens really internally. It accepts this. Before putting into the set, it computes the hash value of that based on the value of this integer object, which happens to be 1, and then it adds to the set. Now similarly, these values are hash functions are computed, and they will all be yielding, because the contents are different, they will all be yielding a different values of hash. So they will be landing into some different areas in the set. But when I give 4, you will have the same hash function coming out, because if you see the property, it should, for the same value of the object, it should give you the same hash function. It should be repeatable. So for this 4 and this 4, it has already computed the hash and added the item. And then when it gets the hash function for 4, again it will get the same hash function, and it will go and see that this object is already there. It doesn't take this value into it. So similarly, the 4, 5, 6 also will not be accepted. So you don't see that these values are added into the set finally when you print it. So what you give is different from what you get. So that you should keep in mind. And why it is happening is also very obvious, but try to understand the reason behind it. Now, what if I add some item to it? This is a new item which is getting added, and it should accept it. So 71 gets added. Similarly, you can add any other item, different items. If you add, it will be able to take it. So let us try to add some more, because I want to remove some items later on. Now 70, if I give, it doesn't matter whether you are giving this. Now what if I give, maybe let us do the same 70, I give it as a string. So do you expect this to accept it or reject it? It accepts it. The reason being, this is an integer object and this is a string object. So though the contents are, for us as a human being, is same, but at the same time, literally this 70 will be converted into an integer value, which is totally different from the ASCIIs of, or the UTF-16 encoding or UTF-8 encoding, whatever encoding it has, that value will be different. So you will see that these two objects are not the same, and it will result in a different value of hash, and it will get added successfully. It doesn't reject it unless they are same kind of objects you add it. Now, there are two ways to remove an element from a set. So let me remove it. There's a remove command. So let me give the same number, which is already there. Integer 70 got removed. Now, what if I give a remove command an object which is not there? Suppose 7 is not there in our set. So let me try to give an object which is not in the set using the remove command. So you get an exception. You need to be careful before you use this remove command with any item. You need to make sure that it is a part of that set or not. So there are commands which I told you. Let me show you that. There are a set of commands which you can use to find out X is in, yes. So this to be, you have to check it whether it is true, then only you should give a remove command. Otherwise you will get an exception. So let us comment it off. Now what if I want to do really remove an item which I don't know whether it is already there or not, but I want this to accept it, then you need to use another command called discard. Even if the item is not in the set, no exceptions. Right. Okay, I should not write it beyond some 80 column as per the Python law. So let me not write it. Let us not violate the rule. Okay, I am coming from C++ world. So, okay. Now, what happens? Nothing happens. If the item is not there, it quietly accepts it. It doesn't give you any error. So you are happy. Now, let me try out some functions. If you want to check it, whether is it a subset of some set. So if you want to compare that, so I will say my set. Maybe I will write 1, 2, 3, 4, 5, 6. Your set. Maybe I'll keep 4 of them, 3 of them. So there are some functions which we can use it. Print your set dot is subset of my set. What do you expect? My set, is it a subset of your set? Do you expect this to be false or true? Your set is a subset of my set. Okay, so we are using the is subset on your set. So this is the object, this is the method. We are checking whether this set is a subset of this my set. Since 456 is a subset, you get a true value. Okay, so remember, with respect to what we are invoking it, we are invoking it with respect to your subset, whether this set, your subset, your set is a subset of my set. Okay, so let us do the other way around. Oh, sorry. Oh, I lost it. Now, let me do it in the other way. My set, I want to check whether this is yes subset of your set, which is false. So you should understand what is what. Now, let us use this. Now, is superset is what? It has got all the items of your set in it. Okay, so it is a superset. My set is a superset of your set. So that will be true, and the other way around will not be true. That is very obvious. So I don't need to use it. So let us use union function. Print my set union your set. So you, because this is already there, your union will be this only. What happens if you do it the other way? You will get the same value because both are same. It's very obvious. So anyway, I will, for the completeness sake, I will give it. This also should be the same. Now let us do the intersection of this. If you want, I can show you the Maybe I will use the code that I have instead of typing. I think I have made it very small, big. So a very, you know that intersection is 456. So let me now go little bit, go quickly. I will take something from here one by one maybe. Okay, I'll take both. I'm sorry. To save time. The difference between my set and your set, and symmetric difference. So if you recall, I mentioned it already. Symmetric difference is this, which are not in both will be shown on the green color. Okay. So what do you expect to see? Diff is between these two, my set, difference, your set. So my set is a bigger set, that will give you 1 2 3, whereas your set is a subset of my set, so you will get a null set. So a null set will be printed like this. It will not print a empty parenthesis, because the empty flower bracket corresponds to a empty dictionary. So when it finds a empty set, it will print it as set, like what we did for creating an empty set. The same thing you get it when you are printing it also. So it will not print as a empty parenthesis, flower brackets, because that corresponds to empty dictionary. And symmetric difference is what you saw here between A and B, elements in either A or B, but not both. So in our set, what is there in either in A or B, because 456 is already there in both, only 123 is there only in one set and it is not here. So you will get 123 as a symmetric difference. Even if you do it the other way also, the same thing happens. Okay, between two sets, which is not there in both, are printed out, so you get the same values. So I hope this is very obvious. Let us do the iteration. I will use this code. So we can do a iteration on on the set. See here, we are having all the immutable objects, a tuple with immutable objects only. Okay, and then this is an immutable object. They are all immutable, and then you are forming a set. And if you want to add 4, you can do that, and then I am printing it. So very obvious what you get. I'm printing out all the items. Now see here, I have added it in this order. I'm getting also in the same order in the iteration. Okay, it happens to be like that. Now let me do something. Okay, what if I try to add a set with a tuple objects which have, okay, let me, instead of this, let me have a my tuple with some couple of immutable objects and then one mutable. Now if I say I want to add this, my tuple is a immutable object by itself, but it has a mutable object in it. Okay, so it is unhashable. The list in, understand this. Now tuple itself is immutable. Okay, you cannot change it now, but we know that a tuple can have a mutable object which can be modified also. If I have a list which is mutable, tuple allows it, but that tuple, though it itself is immutable, it cannot be added to a set, because as I mentioned, whenever when you are adding an element into the set, it first finds, it goes into the content of the object, it scans through the complete object to get the hash value. Okay, it is something which is related to the content of an object. So when it is going through this content, it sees that, okay, these two are immutable, it's acceptable, but it sees a list. Now, the issue here is, right now it can find out a hash value based on these contents 2 and 3, and then it can even allow you to add this tuple into the set. The problem is, what if this my tuple gets modified, because it has a list which can be changed. So if I do that, now next if I give my tuple, it will not be able to get the hash function which is same as what it found earlier. Suppose if I don't know whether I'm making sense or not. Let me try to explain it with maybe writing something. See, what happens is, I have added it now. Adding is not a problem because this has a 2 and 3. Only these two values are there. It can compute the hash function value, taking these contents, and then it can add into the set. Now, later on, I may have this my tuple which has modified this 2, 3 to some 2, 3, 4. And now it is inside my set. Now, next I am asking, is a subset, okay, or is it element is available or not, whether this particular element is there in the set or not. If I try to find out, how will it know? It has to now compute the hash function. Now it will find the hash function, but now when it computes the hash function, it has to compute it based on this 2, 3, 4 value, which will be different from what it computed earlier. So this object, though it is still present, my tuple is still pointing at that object, it will not be able to locate it because the new hash function will be different from what it computed earlier because the object has changed. So it will be a inconsistency. The object is still there, but you are now going to add into a new thing, or this will be lost forever. It will not be found later on. So as per the because of this logic, it doesn't allow you a tuple with a mutable objects in it. So it allows this tuple it allows, but this it will not allow. So we need to avoid doing it. Okay. So let me comment off this. I hope this is clear. Please let me know in case you have some doubts. Let me see whether any questions are there or you guys are. Oh, sorry, there is some question. So after line 17, will my set 1 and my set 2, will they refer to same location since their contents are same? Good question. Let me look at the, I don't know, now 17 and 18 would have changed. Let me see. No, it will be same. I hope it is not modified. What is the question? My set 1. Okay, what was the content? Let me run it. This is 1, 2, 3, 4, 5, 6. Yeah, this 4, 5, 6 also same. Okay. Okay, let me understand the question now. Will my set 1 and my set 2, will they refer to same location? See here, these two are two different sets, okay? What I mentioned was within the set, the keys are maintained, okay? It will not go across the set to verify that, okay? It is like two containers, two different containers. My set 1 is one container, my set 2 is another container. This has got a set of same item 1, 2, 3, 4, maybe 1, 2, 3 suppose. I am creating another container with 1, 2, 3. Now whenever I am adding something to it, it is going to look into this key or hash value and then going to add something or delete something. So there are two different things. So there is no relationship between them. It is like I am having a same book. You also have the same book in your house. It's okay. Is that clear? If am I answering this question, Akash?
Hello,
You
sir.
understand? Yeah.
So, sir, I was asking like both the sets, my set one and my set two, they compute hash on like one, and other one also like computes hash on one. So they will be two different hashes on the same value of one.
Okay. Let me try to understand it. Okay. Now, in case if you are asking me whether they compute the same hash or not, let us check it out. Okay. There is a function hash which will give you what is the hash value it computed. Okay. I don't know whether I can do it on my set. No, I need to do it on a particular element. Okay. Can you come again? What is the question, please? I didn't understand.
So, sir, I was asking like, suppose we have one set, as you said, like my set one containing 1 to 3, and other set also my set two containing 1, 2, and 3, and the as you said, like they work with hashes. So I compute it when I want to access like 1, 2, or 3, I would compute hash on that particular value. Similarly for like my set 2 also, I would compute hash on those values 1, 2, and 3. But since the contents, like there is 2 in my set 1 and there is 2 in my set 2, the hashes when we'll compute on those keys, will they be same hashes for my set 1 and my set 2?
Yeah, you are right. Yeah. The hash value will be same. Let us try to find out. Okay. So yeah, I understood that. Sorry, I understood the question now. So let me do that now. Print. Sorry. Hash of 2. Okay. Let us take hash of 2. Now, where is it? I think, yeah, here, this is the value. 2 gives you 2. Okay, let me see whether what happens when we do a string. You see here, when you try to find some hash value of a string, it gives you this. Okay. Now, let me explain that because you have asked this question. So let me bring it up here. Now, another string A, B, C, maybe E. Okay. Now, what I do, I am trying to find the hash of two strings, which is little different, only one bit different actually. Okay, D and E is a one increment from the ASCII value of D to ASCII value of E. Let us see the value of hash that you get for both. Okay, if you compare the previous run and this run, it is ending with some 9498, some 2885, 9498, 2885. So it is repeatable. The hash value computed for the string on every run is not random. It computes the same value on every time you run it. Okay. Now I change one bit in this one character here in the string. What I get a hash value is a totally some different number altogether from what was found for earlier. This is what is called equally distributed. Okay, this the property that I mentioned somewhere, that hash value that you compute distributed equally. Even if there is a small change in the value, they are drastically different. That's why the collision doesn't happen. Okay, if that's how this hash function works. Okay, to answer your question, for my set 1 and my set 2, when it is computing the hashes for these values, it will get the same thing, okay? Because we saw that for 2, it computes 2. Actually, this hash happens to be for integers. They just return 2. I don't know, okay? It's how it is done internally. What is the hash value done? How it is computing. So it is same, okay? Maybe let us try to see whether I may get for 3 what I get. Then the equally distributed may not work, whatever I claim. Let us see what happens for 3. It computes the same thing. For integer values, it is same, but for any string or any other objects which are content of them, it gives you some different values, okay? So that's how the hash function is used. I think internally, this is the hash function which is used by the set to compute and then populate the element or access the element inside the set. Okay, that's what I learned. Maybe this is how it happens. Okay, hope Akash, I answered your question. It will compute the same value. Okay,
Yeah, okay, thank you.
is it clear?
Yes, sir.
Okay, thank you. Okay, this fellow is distracting. Okay, now let us see some more stuff, some interesting stuff, anything that I can show you. Now let us look at the enumerate. I think that we have to see that enumerate is there. So let me take out from here. Will it be interesting? No, I don't think so. So this I'll just show you for demonstration purpose. I already told you list is not acceptable at all as a element. So if my set is there already, I think some my set is there. So I try to add it. Now what happens? I am adding a list with the L1 and L2, a list containing a list. Okay. It will give you unhashable. So that I already explained, I think. So let it be there. I think the same update also. Update is adding it. We're now adding some element to the thing. Add is one thing. Update is another one. You can use it. Okay. To add some new element into the existing set. But it will verify always whether it is able to get the hash or not. And mutable objects are not accepted at all. So that is clear. Now let us see, we can do some pop. Okay, now this is interesting. Let me show you some pop function. Before I pop something out, I want to print it. Okay. So my set is having this element. When I pop it, it happens to get the first element, but it is not guaranteed that you always get the first one. Okay, so it depends on what exactly. It's a random arbitrary element is removed. Okay, it's not always the first element that you added or what is there. There is no order maintained within the set. For be clear on that. Now, okay, let me update one mutable object, immutable object. I always get confused. Now my set is having some values. These are the values, and I want to update with another element, one more element, so that it accepts. Now you may wonder that this, when I update it, okay, let me ask a question now. Based on what you see here, can you tell me what is happening? When I updated a string and then I printed the my set, what I get is this. Can someone tell me what is happening?
Sir, unpacking.
Sorry?
Unpacking the string.
Yes, you are right. Okay, unpacking the string. So it unpacks the string and then adds it to the set. Okay, so we didn't say that, but it does it. So that update takes the object, unpacks it, and then element by element it goes into adds it, and it will also check whether already that element is there or not. So now let us see that whether it happens or not. I will copy paste. I will say okay, two more element, two more. Okay, similar. Or I'll write similar element. Now it is going to unpack it, and then this element, this E, L, M are not going to be added now. Okay, so after adding similar element, so you will see that LEM, this capital M and small m are different, and element, they are all only one element is there. It doesn't accept. So it is very careful in making sure that duplicates are not added into the set. Now, what if I want to add it as a whole string? Okay, how do I do it? Update is not the function to use. You can use add function. That's the difference between update and add. Using add to pass the entire string, okay, as an element, okay, entire string, okay, to add. Okay, I don't want to say add. So now what happens? Similar element, it completely gets added. It is not going to unpack it or something. So add you need to use if you want to unpack without unpacking if it needs to be added. So let us see what is the description that we saw here. Add adds a single element to the set. Okay. Update adds multiple elements to the set by union of itself with others. So this update function, what happens is, more than saying unpack, it actually forms a set before even passing it. Okay, to be precise, if you need to be very, if suppose in the interview somebody asks you, you don't have to say unpack. You can say that update does a union of the set that you are passing. Okay, it treats this as a set, and then you are calling it on another set one maybe. Now set one is already there, and set is what is accepts, and then it does a union of this with the set one. That means what? Whatever you pass, you should make it into a set first, and then make a union of this and this. So effectively, this whatever you are doing here is equivalent to calling this function with the set, constructing a set. Okay, let me show you. It is similar to calling this as set and doing it like this. Okay, it is similar to this, and anyway, of course, it will not add anymore because you have done it multiple times. You did it here, you did it here, but you are doing it with a set. So this is what is happening here. Okay, this is not unpacking the string and then passing it. It is unpacking it, forming a set, and then computing a union of this with the my set, and that is what is coming out as an operation. The total operation done is this. So if you look at the description, update adds multiple elements to the set by union of itself with others. So multiple elements, it says multiple elements and unions of others. So maybe it may not form a set. It may do a union of that set, every element with this. Okay, it may not do this completely. it may unpack it, and then each element it will union of that with the my set it will do. Okay, so internally it may be doing it. We need to look at the library function to say what is happening. So this is what is happening. Okay, so that you remember. That's what I wanted to highlight. Now enumerate. Yeah, enumerate also I should show you. How much time I have? Another 10 minutes. Okay, maybe 5 minutes. That's all. We will finish it off. Where is enumerate? Did I have it here? Where is it? I am able to see there, and I'm not able to see it. Okay. Now, when you enumerate my set, what happens? It is very same as what you saw with the other collections. It will send you a tuple. Remember, the parentheses are optional for a tuple than a comma. So when you say this, it actually fills it with the index for every element for the element in the my set, and then it forms a, it gives you a list, a index for every element that it is there. Okay, so you know that it is iterable. Okay, and the order in which it takes is based on whatever the hash functions it computes. Okay, and whatever the values come out of my set is enumerated here with an index and the value. So that's what you get. What if I do this with the just one object? Okay, let me enumerate this again. But if I give a tuple, enum tuple, okay. Now print enum tuple. Now what happens is if you do not give it as an individual element, it will not initialize it. It will send you an enum object every time. So now the printing will be like an enum object 0, 1 and 1, 1, 2. If you see that it is the same, except that individually it is not assigned and you are having the enumerated object coming out. Okay. So that's all about the enumeration. And okay, anything else I need to show you? Hash I already told you how it is computing. And this also I already told you, tuple with immutable object and mutable object, it doesn't accept. So nothing more. I think that's all I have. What I have not shown you or covered is about using this, what is it? These symbols, you can also do this by this. So maybe we will try one if you want. What is the time we have? No, almost I ended it. You can try it out if you want. Okay. How to use it with this. Okay. Two sets you can form and then print it. Okay. Let me show only one maybe at least. Just for the completeness sake, print my set 1. It is not there. My set is not there. Okay. So let me create a any other set I have. Oh, sorry, I wrote it here. I should have written it in our class. I have this here. Okay, sorry. Okay. So 2, 3, 4. Let me print what is there in my set, and otherwise we will not be able to make sense out of it. So my set is having all this. My set 1 is having this. I think 2, 3, 4 are the common stuff. So ampersand is for intersection. So that is as simple as this, like a binary operator. You can use it with these operators, okay, which is easier than using those methods given in the set. So I think this is enough for set. I think whatever I wanted to cover, I have already shown you. Any questions from anyone? Okay. Yeah, okay, you have answered it. Any questions from anyone? Hope this is clear. Okay, so let us stop now. At least you have a 10 minutes break before you get into another class. I don't want to hold you. Have a nice evening, late
Excuse me,
evening,
sir.
good night. Yeah, go ahead.
Sir, I have a doubt. In lab third
Yeah.
assignments, we have to
Ah.
initialize the lists of list. But if it is not a
Correct.
list of list, I mean the depth is 0, then it should not be initialized.
Correct.
Okay, sir.
Yeah, I think I have given some examples, right? So you should be able to handle it. Okay, if there is nothing in there, empty list should give you the empty list. Okay. But if you have multiple lists inside them, then you go ahead and initialize it. Okay.
Okay, sir. Got it. Thank you.
Yeah. Anybody having any doubts on the recursion? I hope you are able to do it. Do you want me to show some idea or you can manage it?
Yes, sir. Almost done.
Okay, good. So I think you will be able to do that. So please do it. Okay. Okay. Thank you. See you next week. Bye bye. Good night.
Thank you, sir. Thank you.
Thank you, sir.
Thank you,
Thank
sir.
you. Bye bye.